after they won't subscribe.
Yeah, you gotta be funny with it. You gotta be cool. You gotta be smooth.
No, I don't care if it's a problem. It's not my problem.
You can make money off of that.
Yeah, you could.
Honestly.
I mean, to retire next year. Let this be your second job. It's gonna be a little David vlogger.
No. All right.
Sandy, man.
So here we go. These are application problems. All right. So these are all word problems.
Oh,
Y'all look. Listen to me. Just like you, when someone comes to my desk and says, Miss Davis, would you help me with this word problem? I start to sweat just a little bit. Okay. I start to go, oh my gosh, please Lord help me work this problem right. So are there some times when I just look at a problem and I go,
No.
I don't get it?
Yes.
There are. Y'all, there are times. There's times, sometimes I'll have a problem and I'll come to you guys and I'll go, y'all, I got this problem. In my star math class or something, and I like can't work it. I keep getting it wrong. And I get y'all to help me and they'll go, oh, you just didn't see this, Miss Davis. All right, so it happens to us all. So here's what I do for you. Because the object of a test is for you to show me how much you've learned, right?
Yeah.
So when you made an 85 on your test, to me, that should say that you know 85% of the material that I taught in this class. You can successfully work 85% of the problem and do a good job on it, okay? The object is not for me to trick you. Do sometimes you get tricked?
Yeah.
So what I do is I usually have some bonuses on the test. Not always, but usually, okay? And so that kind of helps take care of that if I accidentally tricked you and I didn't mean to, okay? All right, so here's my first problem. There's only 4 of them, all right? So here we go. Stephen, would you catch that door and shut it, please? It's coming out. I was killing a bug, sorry. All right, so here's number 1. I'm gonna read the whole problem first, okay? And all I want you to listen for is what are we trying to find? What's my variable gonna be? What does it represent? Does everybody understand? Okay, so the Acela train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours, and what is the average speed?
It's pretty high.
So what is X?
Distance.
The average speed,
Never mind.
okay? It says, what is the average speed? What's another word for speed?
Miles per hour? I don't know.
Yeah, or what else?
Distance.
No, distance and speed are not the same thing.
Distance over
Oh,
time.
yeah.
Velocity?
Fast.
Yeah,
Rate?
Rate.
Rate.
Oh, I thought.
rate, miles per hour, okay? Think about that, that's a rate. Miles are on the top, hours are on the bottom. That's a rate, all right? So, all right, now I'm gonna read it and you tell me when to stop and we need to write something down. The Acela train travels between Washington and Boston, a distance of 457 miles.
Stop.
Okay, so my distance is equal to 457 miles. The trip takes 6.5 hours. My time is 6.5 hours.
There it is.
There it is. All right, what formula am I gonna use?
B times T equals R?
The other way, R times T equals D. Rate times time equals distance, okay? Rate times time equals distance. Now, I only remember this one formula. Like this morning, one of the kids said,
Distance over time.
yeah, distance over time equals rate. And I said, yes, that's another way to say this formula. But I only do one formula. I don't remember 1,000 varieties of it, okay? So this is the only one that I stick in my brain and go, you gotta know this, all right? Do I know the rate?
Yeah.
No, go
No,
ahead.
that's what we're trying to find,
That's your
right?
X.
So that's my X.
That's your X.
Times, do I know my time?
Yes.
What is it, 6.5? So I'm gonna use a parentheses instead of a dot, because it has that decimal point,
Got it.
okay? Equals, what's my distance?
457.
Good. Now, how do I solve for X?
You multiply 6.5 times 6. That is divided by 6.5.
Yeah, they multiplied by 6.5, so you divide. And X is equal to. And do you want to do this in your head?
Oh, no.
Okay, so you should have a calculator, right? So, in my calculator, I'm gonna say 457 divided by 6.5.
So like,
70.31 miles per hour.
see, you didn't have to do all that work, you could just go, you could have just done 457 divided by 6.5, and it would give it to you, right?
Yeah? Yes.
That's all it do for the moment.
Okay? Anybody got a question? Everybody okay?
It seems chill.
All right, so let's do example 2. Example 2, we're gonna talk about example 2 a lot, and I'm gonna show you different ways to do it, but I'm just gonna make sure that you have some math skills that I think you should have, okay? So, first of all, I'm gonna draw me a picture, you tell me what it is.
A person's stick.
Yes, okay? Now,
We need to draw this.
Hair.
Yo, what?
Light.
Hang on, what is?
Parachute.
oh, a parachute,
I thought it was.
okay? But wait, that's not all.
Oh, what?
This is on his back.
Backpack.
Parachute,
A kid?
He's a jump trooper.
A kid?
He's a what?
He's a jump trooper.
What's a jump?
A ninja turtle?
For like, jump force, yeah, the guys that jump out the planes.
What the?
Parachute guy.
Say that.
Paramotor. What's this on his back?
Oh, he's
That's a
flying.
fan.
It's a fan,
That's
okay?
a- you
What
got-
is that fan gonna do to him?
They can float this way.
Yeah, and he's gonna stay up in the air a lot longer, okay? And he can go a lot farther distance. Does everybody agree? Okay, so I'm gonna tell you about this paramotorist.
A lot.
So I'm gonna make a little
Draw this.
table,
Am I
okay?
supposed to draw it right now?
At the top, you don't have to draw that. At the top, we're gonna put the time in minutes. And at the bottom, we're gonna put his height
We're doing input and output.
in feet,
Yeah, I'm so confused.
okay?
We write some.
So, 0, when time is 0, 2,000. 1, 1750. 2, 1,500.
He's still falling pretty fast.
Oh. 3, 1,250. 4, 1,000. That's the last one. Okay, so here's my question. What's happening to the guy?
He falls.
He's falling, okay? Is he falling at a constant rate?
Yes.
Yeah,
Yes, how do you know that?
because we use numbers.
It's the same difference between each one.
Okay, it's the same, that sounds crazy, doesn't it? The same difference. And you mean differences in subtraction, right? When you subtract these two numbers, what do you get?
Oh,
Oh, you
yeah,
subtract-
yeah, 250.
250. When you subtract these two numbers, what do you get? When you subtract these two numbers, what do you get? When you subtract these two numbers, what do you get? So that's why you said he was falling at the same rate. Now, do these numbers have anything to do with that?
Not really.
Okay, so let me ask you this. What if this number were 0, and this number were 5, and this number were 27, and this number were like 113? Could you say he was falling at the same rate?
No, he's going up.
No, you could not. Do you understand why? Because these are changing by ones, okay? So, what else could I call this number? In a math problem, what would this be called? The what of the equation? The what? The rate, what is the rate of change?
250?
What's it called though?
X, Y over X.
No.
It's some of the point.
Okay, so what's this guy doing? Falling. He's
Yeah.
going down, right?
Ah.
He's going down, kind of fast, but he's going down. This line is doing what? Slow. That's the word I'm looking for. Okay, so now let's think about this. Are you with me?
Yeah.
Can I say that the slope of this problem is 250?
Yes.
Yes.
puzzled.
Because if the slope of this line is 250, what is happening
When
to
it's
this
going
guy?
out, it's negative.
Oh, there you go. Very
Oh,
good.
because
It's
my graph.
negative 250 because it's going down, okay? The difference in every one of them was 250, but he is going down, so my slope is negative because he's going down, okay? Does anybody know what the formula for slope is?
Y equals mx plus b.
No, that's the slope intercept form of a line.
M equals
Okay.
y sub 2 minus y sub 1 over x sub 2 minus x sub.
Very good.
No.
Okay,
Well, we-
now listen to me. I'm gonna tell you an easier way to say it, okay? Do y'all know what the symbol is for subtraction? There's a symbol that you use in chemistry, and it means you're gonna find the difference in those two. The
Minus.
change in.
It's a square, triangle.
Yes, it is. It's called delta, yes. Oh, you are on it. Delta y over delta x.
Oh, yeah.
Okay? That means the change in y over the change in x. Okay? Now y'all listen to me. This is the only reason that you can use these numbers right here. Now let me stop for a second. Why do you think I'm making such a big deal out of all this?
That's what we're about to learn.
Because one.
Uh-huh, because you might see it where?
Test.
Oh, okay.
Then I
See
can
if
run
you're
it
with me.
down.
Alright, so the reason that I can only look at this number is because these numbers change by what?
One.
Ones. If these numbers had gone by twos, what would you have to have done to this number?
Multiply by 2.
Divide it by two. That's what this says, guys. The change in y over the change in x. Okay? You would have had to divide that by two. But these went by one, so it wasn't a big deal. Alright? Now, what's the most common mistake with the slope thing? Well, kids put the x's on top because in a table, your x's are on top and your y's are on the bottom. So let me tell you some easy things to help you remember to put the y's on the top. Okay, one thing is this. Y'all look at this X right there. He's standing there, got his feet kind of shoulder width apart. Would he make a good base? Could you climb on his shoulders and stand up?
Yeah.
Yes, he would be very stable. Whoa, what about this guy?
He's kind of crooked.
Yeah, and he's got that little round part. What's gonna happen?
You're gonna
fall.
slide.
You're gonna fall, okay? You're gonna fall. Anybody follow, kids getting hurt on Instagram?
Oh, my gosh.
Can't say I'm familiar.
It is funny. Some of them are kind of tragic and I mean, they're not bad or anything. They're little kids and stuff.
That makes sense.
But, no, it is kind of funny though. It is funny. We think it's funny.
She got hit into the road.
So anyway, so this one's not good. Here's another way to remember. You see this Y right here? He's got a tail, so he can hang on up here. Okay? He belongs on the top. Y's on the top, X is on the bottom. All right, that's where your slope. Now, could anybody tell me how high was this guy when he jumped off the cliff?
2,000.
Oh, yeah. So that was his initial height, right? His beginning height.
But that's
And then
a-
he started going down 250 feet every minute. All right? Does anybody know, if I was gonna graph this thing, what would that 2,000 represent?
The
Y.
E0 thingy in the middle.
The y.
The origin.
The y-intercept, very good. My y-intercept, where x is 0, okay? Where x is 0, and then you would go up to 2,000, and then you would use your slope and come down like that. What's another, there's a letter that we use for it too.
B.
B, very good. So it's also equal to B.
Look at her go.
All right, I like that. So we could use this equation, right? Y is equal to mx plus b, and I could write an equation for this. Do you agree? Okay. Now, how do I know that it starts at 2,000? Is that because it's the first number that I come to?
Because it's under zero.
Because that's at 0, okay? Because that's at time 0, then that's where he's gonna start. That's my y-intercept or my b. All right, so let's write the equation.
Oh, yes.
Y is equal to, what's m?
200. Yeah, 250.
And
Negative
what?
250.
Negative 250.
Y'all
Very
forget
good.
a
So
negative.
negative 250x plus what's b?
2,000.
2,000. Okay? Now, what if I told you this? What if I said, really? Oh, well, before we do that, let's talk about one more thing and then I'll show you. Okay, this is a coordinate plane. You know where you graph stuff? This is my x-axis and this is my y-axis. Are you with me? Okay, it's divided up into 4 quadrants. All right? 4 quadrants. Do you know what the names of the quadrants quadrants are?
Yeah, quadrant
Four.
1, quadrant 2, quadrant
Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so which one's this one right here?
4. Oh,
Yes,
okay.
this is 3. So if I'm gonna name it Ace, do I use Arabic numbers?
No,
No,
you
these
use
are.
Roman
Roman numerals.
Okay, Roman numerals. These are Arabic numbers, for what we usually use all the time. Okay? But you would use Roman numerals.
We're using
So
Arabic
where does,
numbers?
this is 1,
Oh, English.
yes.
I thought it was.
This is 2, this is 3, and this is 4. Okay? Where do real life problems take place?
That's just I.
And not on the paper.
In quadrant 1, yeah. Cause this, my time, can you go back in time?
No.
No, you can't. So once you've said something, you can't take it back, can you? You can apologize for it, but can you ever make it go away? No.
With chocolate.
Okay?
No.
So, and then height doesn't go down, height goes up, okay?
What
Once
about
you
old
hit the
people
ground,
dictionaries?
huh?
What about old people dictionaries?
Yes, we do.
So
Yes, we
height
do.
does go down.
My mother used to be 5 foot.
What's
She's
she now,
not
4'3"?
anymore.
She's,
Okay.
she's smaller than that.
Yes, I'm gonna say, I don't think she's 4'10". I don't think she's
Don't laugh,
4'10".
you're not
She's
4'10".
little bitty.
That's all you know.
Okay, so here's my question. This is the only question I'm gonna ask. What is the height after 7 minutes?
I don't.
What is the height after 7 minutes?
Oh, you plug 7 into X. right?
You could do that. I could plug 7 into X. What else could I do?
Continue that.
Yeah, people, listen, if they didn't ask me all this mess down here, I'd take my chart and I'd go 5, 6, 7. Okay? If at 4, it's at 1,000 and it's going down 250 every minute. At 5, it's what? 750.
Yeah, 250.
At 6, it's what?
500.
And at 7, it's what?
It takes him 8 minutes to get to the ground.
That's exactly right. So this is the answer. But you can do that other one. You can go over here and go negative 250, but you had to make that equation up, right? Okay, but you can plug it in. Is there any way that I could know that this equation was correct?
You can check
Yeah,
it.
you can check it.
I could check it with all of these things, right?
I'm good.
Plus 200,000, sorry. So 7 times 0 is 0, 7 times 5 is 35, carry the 3. 7 times 2 is 14, and 3 is 17. So negative 1750 plus 2,000 is, guess what? 250.
You get out here at 3 o'clock, huh?
All right, anybody got a question? That's it? All right, got 2 more problems. Here's my next problem. It's a pretty easy problem. Example 3. Here's what it says. It says you are hanging. Now, what are you listening for the first time I read the problem?
Numbers.
The variable. What's my variable going to stand for? What are we looking to find, okay? It's when it says find, or how, or what, all right? So you are hanging 4 championship banners on a wall in your school's gym. All right, well, we can draw that really quick. Let's draw a wall.
Yes, you are.
Yeah, I love to draw. I'm not good, but I love to draw. All right, so on a wall in your school's gym, the banners are, I'll wait on the rest of it. The banners are 8 feet wide and the wall is 62 feet long. Go ahead and put that on there.
It's a big wall.
What's a gym? Okay?
Every
There
time I go to-
should be, listen, there should be an equal amount of space between the ends of the wall and the banners and between each pair of banners. How far apart should the banners be placed? So what's X?
The distance between the banners.
Okay, so the distance between, lots of abbreviating here, banners. All right, so anybody remember how many banners we got?
4.
4. Okay, so we're gonna make them, they're supposed to be kind of even and symmetrical. All right, so we'll put them in here. Now, they don't have to be perfect because I'm labeling
They
it.
just said it, they gotta be like perfectly placed on the wall.
Okay?
Did you say the width was 8 feet?
Yes, it did. It said that the width of the banners was 8 feet wide. So we'll go put that in each one of the banners.
Some of mine look 4
okay? And then it also told us that the distance between them is what? X,
X.
see? And it also said that the distance between the wall and the banner is the same as between the banners.
So it's X two.
Yes, so it's X also. All right, how many X's you got, people?
1,
Five.
2, 3, 4, 5.
Okay, so 5X plus, how many 8's you got?
4.
What is 8 times 4?
32.
Do you see how I showed you where I got that number? I didn't just write a 32 down here.
Thank you.
I said 8 times 4 is 32, so 32 equals what? 62. I'm solving for X. Tell me what to do first.
Minus 32 from
Perfect.
We need 6 feet.
5X is equal to 30. Divide by 5, and what is X?
6.
So there's 6 feet between each banner and 6 feet between the wall and the banner. All right, everybody got it?
Burn it
Okay,
together, yeah.
one more. 62, they told us the wall was 62, so like total length of that wall. Okay, so last one, example 4. Now this one's gonna be a thinker, okay? This is gonna be a problem you're gonna have to do some thinking on. I'm gonna tell you this. In this problem, we're going to use a skill that I have already taught you this year, okay? We're gonna use a skill that you've never seen or heard about before, but I've already taught it to you this year. So let's see if you can figure it out. All right, so here we go. So the first thing, here's what you're listening for. What's my variable? What am I looking to find? Okay, a car used 14 gallons of gasoline and traveled a total distance of 550 miles. The car's fuel efficiency is 40 miles per gallon on the highway and 35 miles per gallon in the city.
You said 40 miles per gallon?
40 miles per gallon on the highway. It's obviously not a big giant truck or a big giant car. Okay, it's obviously a small car. Yeah, well, it's a small car.
What kind
Okay,
of car?
40 miles per gallon on the highway and 35 miles per gallon in the city. How many gallons of gasoline were used on the highway? So what's X?
How many gallons are you?
Okay, so gallons, the number of gallons used on the highway. All right, so that's my X. Okay, so now I'm gonna read the problem and we're gonna write the info down. Are you ready?
Yep.
A car used 14 gallons of gasoline.
14 gallons.
Okay, so I've got 14 gallons of gas that I used. And they traveled a total distance of 550 miles.
Total distance.
Okay, so 550 miles. Now, I like that word total because when I see that word, I go, oh, I can set this equal to some stuff, right? When I total stuff up, it should be 550 if I'm talking about miles. The car's fuel efficiency is 40 miles per gallon on the highway. So you write this like this,
So
40
1 gallon.
miles per gallon, MPG. And that's for the highway. And it's 35 miles per gallon in the city,
That's crazy, guys.
okay? And that's because in the city you do a lot of stopping and going, which uses more gas, and on the highway you shouldn't be pressing and going off the gas and making people sick, okay? So now I've got to figure out some kind of formula, okay, that I can put this X in and I can solve it, all right? Some kind of equation. Well, I like that this is my total miles. So do you agree that the number of highway miles plus the number of city miles
It's gonna equal.
is equal to my total miles?
Yeah.
What are your total miles? 550. Okay, so always do the easy part first, okay? That was easy, but when you do something like that, your brain goes, whoa, you're so smart, okay? You're so smart. So let's see if we can go over here and figure out how to get highway miles and city miles. Okay, so all I have are miles per gallon. Think about this as a dimensional
Don't
analysis.
say that.
Okay, 40 miles per 1 gallon. Do you agree with that? what could I multiply this by and only get miles?
We doing that little thing.
What if I multiply it by the number of gallons? What happens to these gallons? And you're left with miles.
Hold on, what?
Okay, so here's what I'm gonna do. I'm gonna multiply his miles per gallon times how many gallons of gasoline he used. All right, and that's gonna tell me how many miles he went. So on the highway, what's his rate, his fuel efficiency rate
40
on the
miles per
highway?
gallon.
40 miles per gallon times, how many gallons does he use on the highway?
That's what we don't know. Hey.
That's right, that's what we don't know, so what do we call it? Okay. Plus, what's my fuel efficiency rating on the, in the city?
35.
Times, how many gallons am I using in the city?
We don't know either.
Okay, so could I call it Y?
Yeah.
You can call it
If you call it X, are you restricting it?
No.
Are you saying that I have to use the same number of gallons on the highway that I did in the
They're
city?
different.
Yeah, and they're very different things, so it can't be that, okay? Could I call it Y?
Yes.
If I call it Y, can you solve for X? No, because you'll have two variables in one equation, okay? All right, so we're gonna use a trick.
Imaginary.
No.
Yeah. What? Bro, I ain't got enough room for all this.
Okay?
Oh my God.
Now, let's pretend that I know how many highway miles. Now, obviously, if I knew it, people, I wouldn't be working the problem because they're asking me for it, okay? But let's just pretend that I know how many gallons I used on the highway. So can you figure out how many I used in the city? What if I used 10 gallons on the highway?
That's
How many would be left for the city?
540.
Gallons. If I use
Wait,
10
gallons?
gallons, there you go.
What'd she say?
4 gallons.
Oh, cause you have that 14 gallons. of gas.
That's
I forgot.
exactly right.
I
I
forgot.
used 14 gallons of gas,
I forgot.
okay? So if I use 10 on the highway, I have 4 left for the city. What if you used 8 on the highway? What do you have here? 6. Do you remember doing something like this on another problem? Okay? We're making stuff up to see what we can do. What if I use 2 on the highway? How many will be on the city? 12? How are you getting this number right here?
You're adding them to.
No, we're not adding, you can't be adding. Okay, you're subtracting this from 14, right? 14 minus 10 is 4. 14 minus 8 is 6. 14 minus 2 is 12. Okay? So that's working and it's good. Don't stop. What if I use X on the highway? What is this?
Why?
14.
Don't stop what you're doing, people. So then subtract it. What is it?
14X.
14X.
Minus X. People, 14X is 14 times X, okay?
I knew that.
So, if you're subtracting, then keep on subtracting. Don't be start adding or multiplying, all that kind of mess, all right? You told me that you subtracted this number from 14, and then I asked you about X, and you're like, well, I don't know. All
Excuse me,
right?
Miss Davis, I need Alexa Bridges, she's leaving.
Okay,
Well, we can-
so 14 minus X. So that's what goes right here. We're gonna put parentheses, 14 minus X.
So then you would distribute.
And then you would distribute, okay? So what is 40 times X?
40X.
All right, I like that. Y'all doing good. Y'all doing good.
I like energy. I like energy.
Okay? And then we're gonna distribute. Alexa.
35 times.
So here's the way I'm gonna do it. Okay, some of y'all need to do it that way because you don't ever bring a calculator. So I'm gonna say 35 times 10. 35, see, I'm just using the tens place. It's 350. 4 times 35, let's see, that's 20 and 12 and 2.
The
It's
answer is
140. What's 350 and 140?
You gotta do it
490 minus 35x is equal to 550. Okay, now y'all listen to me. You're gonna have problems like this on the test. and you had problems on the worksheet that you just turned in, and they were like this, and some of y'all did some bad stuff, all right? So what I want you to know is what you should always do is stop right here and collect your like terms.
Yes.
Don't start putting all your X's on one side and plain numbers on the other until you have collected all the like terms on both sides. So I'm collecting those. What is 40x minus 35x?
5x.
God.
Now what am I gonna do?
Subtract
12.
Subtract 490. And 5x is equal to
60.
60. And divide by 5. And x is,
12.
very good. So I had 12 gallons on the highway and 2 gallons in the city. Okay? All right. So I am going to hand you out a worksheet. It will be over 5 and 6. Can you work the entire worksheet?
No.
No, because I only told you 5. Okay? So you can work problems 1 through 8.
Yeah.
Okay? 1 through